The notes for today, so for prep day 1C, talk all about angle measures and different words that we use to describe angles. I went ahead and pre-filled out some of these for you so that you didn't have to take as long waiting for me to write them down. Just make sure that you're careful when you copy down the work and the words and the pictures too. An angle is defined as being a figure that's formed by two rays with the same endpoint. So a ray has an endpoint, and so I have ray BA and I have ray BC that both begin at endpoint B and then they continue on in their directions. So this is an angle because these two rays share this endpoint B. When it comes to naming an angle, I have a few ways that I can do that. I could call this angle ABC. So notice that it goes in the order so that the vertex or the corner of the angle is in the middle. I could also call this angle CBA, again with the B in the middle, since the B is the vertex of the angle. Because there are no other angles that share this vertex or this point right here, this endpoint, I could also call this angle B. And then lastly, sometimes you'll see a small letter or a small number that's here on the interior of the angle, and you can call the angle by that letter or by that number as well. So I could also call this angle 1. There are 4 different types of words that are used to describe angles. So you have acute, right, obtuse, and straight. So number those 1 through 4. Those are the 4 words that you can use to describe how big an angle is. So an acute angle is defined as being an angle whose measure is greater than 0, because if it was 0, it wouldn't be an angle, and less than 90 degrees. So I drew a picture here where I tried to make the angle look like it was less than 90 degrees, and I wrote the number 50 in there. You don't have to worry about notation for any of these because there's no notation for acute, right, obtuse, or straight angles. A right angle is an angle whose measure is 90 degrees. It's exactly 90 degrees. Most often you won't see a 90 written in the corner of a right angle. This little box right here that's seen in the corner shows that that's 90 degrees, so that would be more common. An obtuse angle is defined as being an angle whose measure is greater than 90 and less than 180. And so on the picture here, I chose the number 130, but any number between 90 and 180 would do. It can't be 90 because then it would be a right angle, and it can't be 180 because then it would be a straight angle. A straight angle is the 4th type of angle that we name. So a straight angle is defined as being an angle whose measure is 180 degrees. And so a straight angle, when it's 180, is an angle that's open so far that it makes what looks like a straight line. One ray is going to the right, one ray is going to the left, and they're opposite from one another, which means that they make a straight line. So anytime you see a straight line that's made up of angles, you know that they equal 180 degrees. The angle addition postulate is very similar to the segment addition postulate. It says if C is in the interior of angle ABD, so that just means that C is somewhere on the inside of this angle. And then if there's a ray that goes from B to C, what the angle addition postulate says is, it says this, when you read this out loud, you say the measure of angle ABC, so this piece right here, plus the measure of angle CBD, CBD, so this piece right here, is equal to the measure of angle ABD, ABD, so the whole thing. So what the angle addition postulate says is basically the same thing as what the segment addition postulate says. It says that if you know how big this piece is, and if you know how big this piece is, then this piece plus this piece equals the whole thing. So I put the 60 and the 50 on there. I actually drew them backwards, so I'm going to fix them. But so if ABC was 60, and if CBD was 50, then this says that I can add up those two pieces, so 60 plus 50, and get 110. So if I know how big those two pieces are, I can figure out how big the whole thing is. And what I mentioned before is also true. If they told you the whole thing was 110, and if they told you that that part up there was 60, then you could work backwards using subtraction to figure out that that piece was 50. So even though it's called the angle addition postulate, you can still do some of the things with it using subtraction. So we went through those definitions kind of quickly. Make sure that you practice them. You want to make sure that you're comfortable with those words. What we're going to do right now is we're going to practice using the words given the picture of an angle. So this example in the notes is really the only time when it's good to look at angles that aren't being measured and say that you think you know how big they are. The only angles on here that I know exactly how big they are, because it doesn't say they're drawn to scale, are these two, the second one and the fourth one. But these two I can look at and I can say how big I feel like they think they are. So the first one on angle A, we would look at that angle and we would say that that type of angle looks like it's obtuse because it appears to be bigger than 90 degrees. There are three ways that I can name that angle. So I could call this angle angle A, D, C, with the D in the middle because it's the vertex. I could also call it angle C, D, A, with the D in the middle because the D is the vertex. And then the last way I can name it, because there's no other angles that share that vertex, I could also call this one just angle D. Okay. When you look at angles and they're named with three letters, the one in the middle has to be the vertex because the vertex is like the center point of the angle, if you want to think about it that way. So this next one has a box in the corner, so I know that it's a right angle. And there's three ways I can name that one as well. I could call this one angle YXW. I could call it angle WXY. Or, because there's no other angles that are right here, I could also call it angle X. This third angle looks like it's less than 90 degrees, so I'm going to say that I believe it to be an acute angle based on how it looks. And I can call this one angle LKJ. I could call it angle JKL, or I could simply call it angle K because there's no other angles right here. And then my last angle, it almost looks like it's not an angle at all. It looks like it's a straight line. That's because it's a straight angle. And so for this final example on this page, I could call this angle three different ways. I could call it angle XWY. I could call it angle YWX, or I could call it angle W because the W is in the middle and it doesn't affect the size of the angle whether it's on this side of the line or whether it's on this side of the line. When you're naming angles, you don't put the little letter M in front of them. This M that's right here stands for the measure of the angle. You use that when you're talking about how many degrees an angle is large, but not when you're simply naming the angle. Naming an angle just lets somebody else know that you're talking about the same angle as they are looking at.